Fabulous Chemistry Minions, video number 5. Relative strengths of acids and bases. So before we get too started, we're talking about strong being the lowest part of the pH scale, strong being the highest part of the pH scale, and the middle is weak. And the real differentiation here is, from a chemist's point of view, isn't how concentrated this thing is. It's, does the actual acid or base dissociate completely? If it dissociates completely, it's a strong acid or base, straight up. I mean, I can make a dilute strong acid that won't burn you. Strong means generally it dissociates 100%. So all of that H plus goes into solution. That's what strong means. Okay, they're generally all acids, right? pH values between 1 and 6 are considered acidic because there's a higher concentration of H plus now, which will react and neutralize OH minus ions because they're the opposite. pH 7 is considered neutral. That means there's the same number of OH minuses as there are H pluses, and they just balance themselves out. And then higher than 7 is basic. Okay? That's just the general rule of how we read this. And this little picture is perfect as far as what's what. Okay, where the weak is, where the strong is. So strong acids dissociate completely, generally go from a pH of 0 to 4. Okay, if you get a pH 0, pH 1, that stuff is really going to burn you. Okay. Weak acids, they have an incomplete dissociation, and now we're talking a range of 4 right up next to 7. Remember, 7 is neutral. So once I step down from 7, I'm in the 6 range. I'm instantly slightly acidic. Strong bases, same but opposite. Dissociate completely. Their pH range is going to be from 14 to 11. Weak bases, incomplete dissociation. The range goes from 7.1 to 11. So as soon as I step above 7, I'm basic. Okay? Those are the generalities of using this pH scale and how it works. We've got to be able to create the pH scale. What's going on? It's a log function. And trust me, it's one of the things about math I've never liked. I'm a math guy, but I do not like logarithms. The pH stands for power of hydrogen. And because it's negative log, which means the H plus concentration is technically like an exponent. So a pH of 3 is more acidic than 5, but when I do 3 minus 5, I get 2, and y'all are going to want to say 20, and that ain't right. It's 10. The 2 is squared. It's 10 times every time we have one pH movement. So this is on every test. Okay. A larger number of concentration results in a lower value for pH. So the more acidic I get, the more towards 0 I go. pH of 10 is more basic than a pH of 5, obviously. It's going the other way. The smaller the number, the concentration results in a higher value. Okay, there is such thing as called pOH, but we're not going to go there. So now, here's where the things like in that first example, this is where I've seen it on the test all the time. So if I go from 5 to 3, first you need to know that I'm becoming more acidic. More acidic means my H plus concentration, in the brackets means concentration, has to be going up to make my pH go down. Okay, and in the POGIL, you'll have to solve these with a scientific calculator, and you'll get to feel for it. So not only is it becoming more acidic, but 5 to 3 is a difference of 2 pH values. So that means 10 to the 2. It means it's 100 times more specific or concentrated. It's 100 times more concentrated. Okay, pH difference of 3, 1,000 times. See what I'm saying? So each step on the pH scale is a 10 times change. Each step, because it's a logarithm. pH of 1 means the concentration is 1 times 10 to the negative 1, which is 0.1 molar. pH of 2. Now the 2 goes up in the exponent. See what's going on here? pH is 7. Getting a feel for this? That's what I mean by logarithmic function. Okay, so this, let me check in there. Notes packet. See what you're seeing. Okay, yeah, it's just going to come flying at you. So you're just basically filling this in. So from 4 to 5 is becoming more basic. I'm going up in number. So now my OH concentration must be increasing, and now by a factor of 10 because my pH difference is only 1. If I'm becoming more basic, then I'm obviously becoming less acidic. My H plus concentration must be decreasing by what? Oh, another factor of 10 because it's the pH only moved 1 time. Okay. Now from 13 to 10, I'm going left on the scale. I'm going closer to 0. Therefore, I'm becoming more acidic. My H plus concentration must be increasing. And then I move 3 pH points, so it's 10 to the third, which is 1,000 times more. Notice it's a 1 with 3 zeros. pH moves with 4, it's a 1 with 4 zeros. pH move with 1, it's a 1 with 1 zero. Starting to get a feel for the pattern here. It's going to become less basic because it's becoming more acidic. Makes sense. I'm going to decrease by the same 1,000 times. Good? Good. And with that, we now know strengths of acids and how to play that game. My pH changed by this, so how much did the concentration change by? On to practice and see you in class.